Great. Welcome to another important concept as far as mathematics is concerned. My name is Evans. I'm your mathematics facilitator, and this channel is what Mazris TV. Don't forget to subscribe, like, and share the videos. All right. Good. So, in this concept, we are going to look at what we call polynomial functions. If you may recall, you can recall, remember that we already looked at domain of polynomial functions. We also look at what a function is. Okay, and what did we say about a function? We said that a function, so if you have forgotten, then let me remind you what we said about a function. So we said a function is also a type of relation where we have element of one set called the domain corresponding to only one element of another set called the codomain. Yes, one element of the domain corresponds to only one element in the codomain, then we say it is a function. Yes, that is what we did. So we looked at the domain, how to find the domain of a polynomial functions, how to find the domain of the rational and radical function. We looked at all these concepts. Yes, we also talked about the range of a function. We also looked at the inverse. We have also talked about composite functions. Yes, so if you have forgotten all these, then you need to visit the previous lessons. We did all this once. So today's topic or today's concept is going to be polynomial functions. So what are we going to look at all in this concept? In this concept, we are going to look at what a polynomial is. We shall also look at some terminologies in terms of the number of terms of a given polynomial functions. We shall also talk about the various types of polynomial functions. So this will be our lesson today. Okay, if that is the case, then let's quickly look at what a polynomial is. All right, good. So what is a polynomial at all? Now in this lesson, we are saying that a polynomial is an expression which is the sum of terms involving only positive integral powers of x. Yes, so when you sum up some terms which have positive integral powers of x, then we say it is a polynomial. So remember that a polynomial cannot have a negative or fractional power of x. The moment you realize that the exponent or the power is negative or fraction, then it ceases to be a polynomial function or a polynomial. That is what we are saying. Okay, yes, that's it. So let's look at how a polynomial is written. Let's look at in the form of how we can write a polynomial function. All right, good. So a polynomial function is written in this form: f at x is equal to a subscript 0 x exponent n plus a subscript 1 x exponent n minus 1 plus a subscript 2 x minus x exponent n minus 2, and it can go on and go on and go on until the last n, which will be a subscript n, and that will be the last variable or the last term. Okay, so you can have as long as many terms in a function. Yes, so when you see an expression or a function of this nature, then you know that we are talking about a polynomial function. So let's look at some examples of polynomial functions. Okay, so for example 1, we can talk about f at x is equal to x squared plus 2x plus 1. So you realize that the x squared, the squared is positive, right? Good. It is not a negative power, or it is not fraction. Once there is no fraction or a negative power here, then we say that this is a function. Okay, so you can also talk about example 2, where we have x exponent 3 minus 5x exponent 2 plus 4x minus 3. Yes, and we can also talk about the example 3 where we have h at x is equal to 5. And most of the time when students see the example 3, they argue. Yes, you don't have to worry yourself, you don't have to be confused. Yes, so always when you see examples like this, you can say this what a constant what polynomial. Yes, we can have a polynomial like that. Okay, you see that we don't have what the unknown variable, which is x. There is no x attached to it. Doesn't mean it is not a polynomial. It's also what a polynomial. So take note of these examples. Okay, good. Now let's also look at the some terminologies given to polynomial in terms of the number of terms. In terms of the number of terms, you can have a polynomial of 1 term, can have a polynomial of 2 terms, a polynomial of 3 terms, 4 terms, 5 terms, and so forth. Okay, so let's quickly look at those groups of polynomials. So a polynomial of only 1 term is called what? Monomial. Yes, that's the term given to a polynomial. So when you realize that we have this polynomial with only 1 term, then it's called monomial. So for the example 3, okay, for the example 3, you see that we have h at x is equal to what? 5. This one has only 1 term, and that is called what? A monomial. A monomial. Okay, great. So once you realize that we have such polynomial, then you can call it what? That. So let's look at some examples, and you can talk of what? 2x squared. You can also talk about what? 4x. You can also talk about what? 7. So all these are examples of what? Monomial. They are, because they are only one term. Okay, so take note of these examples. Now let's also look at a polynomial of 2 terms. So when you have a polynomial of 2 terms, it is also called what? Binomial. Binomial. Yes, so the moment you see you have a polynomial of only 2 terms, then it is also called binomial. So let's also see some examples of those. Yes, so you see that we have x plus 1, and you can see that it's what? Only 2 terms. So we have x, which is 1 term, we have 1, which is also what? 1 term, and that makes it what? 2 terms. In that case, it is called what? Binomial. You can also talk of what? X exponent 6 minus x, and that also term this as what? A binomial. And also we have this example as well, which is also a binomial. Okay, let's look at another term, and we are also saying that polynomial of 3 terms is called what? What name? Now yes, what name? Think about this. What do you think will be the term or the name given to polynomial of 3 terms? So if you have trinomial, then you are right. Yes, so that is what? Another term. Okay, now you see all these terminologies that we are using for here. I know someone may also ask, what about if you have 4 terms, 5 terms, 3 terms? Yes, so apart from these 3 terminologies here, the rest from 4 terms, 5 terms, 6 terms, and so forth, they do not have specific what terms. So if you see any polynomial of what 4 terms, you don't have specific term like these 3. You can just see what? A polynomial of 4 terms, or a polynomial with 4 terms, and you are good to go. You can say a polynomial of 5 terms, a polynomial of 6 terms. But in the case of 1 term, 2 terms, 3 terms, then you can give them these specific what? Names. Yes, so take note of all this. So let's look at some examples of a polynomial of 3 terms. So you can talk about this where we have what? X squared plus 2x and plus 1. So you see that x squared 1 term, 2x another term, and 1 another term. That makes it what? 3 terms, and that is what we term it as what? Trinomial. Okay, great. Now we have another one here. And then so all these are examples. Okay, great. Now let's quickly look at the various types of polynomials. Yes, we are going to look at the various types of polynomials. Okay, great. So when you are asked to mention some types of polynomial functions, what are some of the types that you may think of? Yeah, so these are some of the types that we can. So if you have the first one on our list, what do we have? What constant functions. Now remember, in the previous examples that we gave of examples of polynomial function, in the example 3, we said that each at x is equal to 5, and we term it as what? A polynomial function or a constant function. Why did we say it's a constant function? It is a constant function because there is no unknown variable attached to it. That's why we said it is what? A constant function. Okay, so when we say a constant function, what is a constant function? Now for a constant function, we are saying that this is when the range of a given function has only one member. Okay, yes, when a range of a given function has only one member, then we can term it as what? A constant function. Now in a constant function, we are saying that the highest degree or power of x is 0. Yes, when you have a function which has only constant, then note that the highest degree of that function is what? 0. So that is what we are talking about. Okay, so for a constant function, what you are going to do is that you should be able to identify those functions from the other functions. Okay, so let's look at how we can write a constant function. Okay, so a constant function is of the form f at x is equal to c, where my c is what? Is constant. Okay, so that is what we mean by what? A constant function. Okay, the moment you realize that you have this nature, then we term it as what? A constant function. Do you get it? Yes. So let's look at some examples of a constant function. So we can talk of the first one, which is f at x is equal to 3. So in this case, you realize that the 3 is constant because you don't have any unknown variable attached to this function. If that's the case, then we can say that that function is what? A constant function. Let's also look at another example where we have 12, and 12 also what? Or negative 12 is also a constant function. Okay, so all these examples are all what? Constant function. Okay, so you realize that a constant function, the value what stands alone, it doesn't have any unknown variable attached to it. So let's look at the graph of a constant function. For the graph of a constant function, we are saying that it is parallel to the x-axis. Why are we saying it is parallel to the x-axis? Yes, that is when you realize that that graph and the x-axis move in the same direction. When you realize that they are moving in the same direction, then we say that it is parallel. Have you gotten that? So let's see how that graph looks like. Okay, yes, so for the constant function, you realize that we have our x and y axis. Okay, yes, so when we have x and y axis, then you realize that we have what? The line, which is the graph. So the red line drawn here is the constant function, where we have the constant what? C there. So you see that that line and the x-axis, they are moving in what? The same direction. In that matter, we can say that is parallel to what? The x-axis. So that is what the nature of the constant function. That is the graph of a constant function. Okay, yes. So let's also look at other types of what functions. Okay, so in the first place we have looked at a constant function. Let's also look at other types of what functions. Okay, all right. So in example 2, we have what linear function. We have linear function. What do we mean by linear function? So when you hear linear function, what comes in mind is what? A straight line. A straight line. So always a linear function, what? It gives the shape of what? A linear or a straight line. Have you gotten that? Great. So when we say a linear function, then it is also given in the form of, so a linear function is given as what? F at x is equal to mx plus c, where our m is the gradient or the slope, our c is the y-intercept, and the m shouldn't be 0. Okay, so here what we are saying is that for the m, which is the gradient or the slope, that is what we are talking about. We mean what? The steepness of the graph. Okay, the steepness of the graph. When we are talking about the gradient of the graph, we mean the rise and the fall of the graph, whether the straight line rises or it falls. Okay, that is what we are talking about. What? The slope. Okay, the slope, when you are rising and you are falling, that is what the steepness of the graph, and that is the m we are talking about. And the constant also gives what? The constant, which is c, gives what? The y-intercept. In that case, m shouldn't be 0. What it means is that the moment m becomes 0, then it means that the function ceases to be what? A linear one. In that case, it becomes what? A constant function. That is why we are saying that m shouldn't be what? 0. Good. For a linear function, what is the highest degree of a linear function? And we are saying it is what? 1. So you can even see from the function itself, f at x is equal to mx. So you see that the x has what? Degree 1. Have you gotten that? So that makes it what? A linear function. Okay, let's look at some examples of linear functions. So for our first example, we can talk of what? F at x is equal to x, which is what? A linear function. So when you see such example, we term it as what? A linear function. And then we have our example 2 as well, which also gives us what? G at x is equal to 2x minus 3. And then we have example 3, which also gives us what? H at x is equal to 2 multiplying the expression x minus 1 plus 5, and that also gives what? Example. Okay, and then we have the last example, which is p at x is equal to half x plus 4. All these you see here are all what? Examples of linear functions. Okay, now let's look at the graph of a linear function. So for the graph of a linear function, we are saying that it's a straight line where we have our y equals what? Mx plus what? C, which has a gradient m, and the y-intercept. We've already talked about the gradient, where we are talking about the steepness of the graph. We are talking about the rise and the fall of the graph. Okay, and the y-intercept, we must have what? 0 and c. The 0 means if you are talking about the x, the y-intercept, then my x should be what? 0. That's why we have 0 there. And as we said, the c becomes what? The y-intercept, and that's the coordinate. So the coordinate of the y-intercept is the 0 and the c. All right, great. So let's look at the nature of the graph of what? A linear function. Okay, so we have our x and y as this. Okay, yes, and then let's see how the graph. So you see that the red line is what? It's a straight line. Okay, it's a straight line where we have what? The point c and the coordinate 0, c, and that gives what? The y-intercept. Okay, yes. So we have the point c and the coordinate where we have x to be 0 and y to be c, and that gives what? The y-intercept. Now let's look at the x-intercept part where we have the point negative c on m. So if you take that rule or that relation where we have y is equal to mx plus c, then for x-intercept, my coordinate or my point will be what, negative c on m, where we have the coordinates we have the coordinates, that's negative c on m and then 0. So it means that here our x-intercept is what, that coordinate. Okay, that is our x-intercept. So this is the nature of what, a linear function or a straight line. Okay, this is the graph of that. So let's look at other types where we have what, our third type, which is what, quadratic function. So we are saying that quadratic function is given in the form f at x is equal to ax squared plus bx plus c, where our a, b and c are all constants and our a shouldn't be 0. So why are we saying a shouldn't be 0 again? It means the moment a is 0, then this function ceases to be what, quadratic function. In that case, it becomes what, a linear function. Okay, so now you see that anytime we talk about what, quadratic function, a quadratic function, we can also term it as what, it gives what, a parabolic what function. Is a quadratic function also what, gives what, a parabolic what function. So that is how we write quadratic function. Let's see some examples of quadratic functions. Good, but in this case we are saying that the highest degree of a quadratic function is what, 2. So you can see that in the relation there where we have a x squared. So you see that x is squared, that's the highest degree. So for some examples of quadratic equation, we can talk of what, f at x is equal to x squared plus 2x plus 1, and then we can also talk about j at x is equal to 2x squared minus 1, where we can also have example like h at x is equal to x minus 1 multiplying another expression x plus 1, and then we can also talk about p at x is equal to what, an expression x minus 3 all squared. Yes, so these are also examples of quadratic functions. Okay, now let's look at the graph of a quadratic function and how it looks like. Okay, so as I said, the graph of quadratic function gives what, the graph of a parabolic what function. So for a parabolic function, then we can have what, the u shape, and in having the u shape, that is when the a, which is the coefficient of the highest degree of quadratic equation, that is x squared, is greater than 0. So the moment you realize that the coefficient of the x squared or the highest what, degree is greater than 0, then we are going to have what, a parabolic function with u shape, and in that case we are going to have what, a minimum curve. So the curve is going to be what, minimum. Okay, and it's going to be a u shape. Okay, and when we have the n shape, that is where we also say we have what, the maximum curve, and in that case the a should be less than 0. Okay, so when a is less than 0, we are talking about the negative. Okay, the moment you realize that the coefficient of x, okay, x squared, or the coefficient of the highest degree is negative, then we are talking about what, the maximum what curve. But when you realize that the positive, we are talking about positive figures of a, then it means that we are going to have what, a minimum, which is what, u shape. Okay, so let's quickly look at how the graph of these nice functions look like. Okay, yes, so we have our x and y axis. Okay, then we can talk about this curve. Okay, so this is what, the u shape, and if the moment you realize that you have a u shape like this, then what are we talking about? We are talking about what? A minimum curve. Okay, a minimum curve where a is greater than 0. Then we can also look at the other type. Okay, yes, so then that one too, we have it like that, and then we have the N shape, and it gives what? A maximum curve. So let's look at the fourth type, where we have what? Cubic function. Cubic function. So for a cubic function, it is given as what? F at x is equal to ax cubed plus bx squared plus cx plus d, where the a shouldn't be 0. So always you should know this condition, so that when you see them, you know which of these is a cubic function, which of these is a quadratic function, or linear function, or what? Constant function. These are the various types. Okay, so for cubic function, what is the highest degree? The highest degree is what? 3. Okay, yes, so you can see that the highest is what? X squared. Okay, so looking at this, you see that we have examples where we have x squared, x cubed plus 2x squared minus x minus 1. And example 2, we also have 3x cubed plus 1, where we have the first expression, x plus 1 in a bracket multiplying another expression, x squared plus 2x plus 1. And all these are examples of what? Cubic function. So let's also look at the nature of what? A cubic function, how the graph of a cubic function what looks like. So you can see that we have the following graph, where we have our x and y axis for the first graph, and then we have this curve. So you see that we have, this is what? The first graph, that is the nature of what? A cubic function. Okay, so whenever you are asked to draw a cubic graph, know that you are going to have it in either this form, or you may also have it in either this form. Okay, so this, yes, you can also have it in the second form. Okay, yes, so how this function looks like, that is what? The nature of the cubic function. Okay, now we can also talk of the other types. Right now we have talked about how many types. We've talked about constant function, we've looked at linear function, quadratic function, and cubic function. So we've talked about 4 functions. Now there are other functions that we can also talk about, but for the purpose of this lesson, in this case, we shall be looking more into what? The first 4 that we have talked about. Okay, yes, so let's look at the other types, where we can also have what? I can talk about what? Quartic functions. And when we say quartic functions, we are saying that it is also given as that's where we have the degree of what? 4. So when we have degree of 4, it means that we have what? Quartic function. And then we can also talk about quintic function. That is what? It also has degree of what? 5. So when you have the degree to be 5, then we are talking about what? Quintic function. We can go on and go on and go on. We can even talk about what? Sextic function. Sextic function. Then it means that we are talking about what? Degree of what? 6. Okay, you can continue and continue. Okay, so these are some examples or some types of what? Polynomial functions. Okay, but our main focus will be on the first 4 that we have talked about. Okay, so this brings us to the end of this lesson. Okay, yes, so we shall end here and continue next time. Okay, yes, so this is what? Maswis TV. I'm your facilitator, Evans. Okay, yes, so don't forget to subscribe to this channel. Okay, like the videos and share. You can also go to the comment section and add your submission. All right, good. Now in our next lesson, we are also going to look at how we can add, subtract polynomial functions. We shall also look at how we can multiply what polynomial functions and also divide polynomial functions. Okay, all right. So this brings us to the end of today's lesson. Now, see you next time. Bye bye.